Well, in this video, I want to look at graphing linear inequalities in two variables. Variables we're going to use are x and y. And so we have looked at graphing linear equations in x and y. And the first step in graphing a linear inequality is to graph the corresponding linear equation, and then you can use that as a guide to draw the graph of the inequality. So the one I'm going to look at is on the screen. It's 2x plus 5y less than or equal to 20. So what we want to do is draw a picture, which in that picture is going to be to shade in a region of the xy coordinate plane. And what we shade in is going to be the graph of this inequality, which means that every point where you're shaded, the coordinates of that point, the value for x and value for y, if they were put in here for x and y, would satisfy the inequality, which means it would be true. If I put in like 2 for x and 1 for y, 2 times 1 is 2, 2 for x, 2 times 2 is 4, and then 5 times 1 is 5, plus 4 would be 9, which would be less than 20. So x2 and y1 is one of the literally infinite number of solutions to this inequality. And this region we're going to shade is the way we can picture all the solutions. You couldn't write them down one by one, there's just too many. Now, so to do it, we want to graph this equation. The equation that goes along with this inequality is found by just changing the inequality sign to an equal sign. And so we graph this equation, going to use that as a guide in drawing the picture of the solution to this inequality. Now the procedure is you're going to graph the equation, which is going to be a boundary line formed by replacing the inequality sign with an equal sign. You graph the boundary line as a dashed line, a broken line, if it's a strict inequality, got no equal sign with it. That indicates that the line is not part of the solution graph. And you graph the boundary line as a solid line if the inequality includes the equal sign, which means that the boundary line is going to actually be part of the solution. The points on the line will be part of the solution. After you graph the boundary line, one way you can do this is you choose a test point that's not on the line. It can be any point not on the line. Then you evaluate the test point coordinates in the inequality. And if substituting the test point coordinates into the original inequality results in a true statement, then you shade the half plane that contains the test point. And you shade on the side of the boundary line containing the test point. If when you substitute the test point coordinates into the original inequality, it results in a false statement, then you're going to be shading the half plane that does not contain the test point. You shade on the other side of the boundary line, the side that does not contain the test point. There is another way you can figure out where to shade, and we'll look at that after we do it this way. Okay, so the inequality we're going to graph the solution to is this right here. And what we want to do first is graph the corresponding equation, which is this right here. And we're going to graph it as a solid line because the inequality symbol includes the equal sign. So the solution is going to include the line. Then we pick a point not on the line. I'm going to use the point 1, 1. Visually, we'll see that's not on the line. When I substitute the coordinates of this test point into the inequality, So here's the inequality, putting in a 1 for x and a 1 for y using that point. You get 2 plus 3 is 5, and 5 is strictly less than 12. So it satisfies, less than or equal to 12. So it results in a true statement when we put this 1 for x and 1 for y in. That means we shade on the test point side of the line. Okay? So there's the line, and what I can actually do here is I can take my my pointer and turn it into a pen or a highlighter. If I turn it into a highlighter, and if I don't like that color, I can go I can turn it into a highlighter that's a different color. Maybe I want to make it red, keep the lines red. Now, kind of got ahead of myself because I need to put the point in. Well, I can draw it with this, I guess. The point that I tested was 1, 1, so that was going to be a point, about right in there. And we can see at that point, which when I checked it, turned out to be true, the inequality. So that means we're going to shade, over here on the on that side of the line. So we shade all this in. Now I can actually just give my pointer back to myself, and if I click, there is the point. Point is on this side of the line, so if I click that point 1, 1, I would be shading down here on this side of the line. So that's what it would look like, a little bit neater, you might say. Now, an alternative is you can take this inequality and actually solve it for y. Now, that's kind of a dangerous alternative because you could make a mistake going from here down to here, and that's going to throw you off. But if you were comfortable with taking the inequality and solving for y, and you don't actually need a test point anymore, because y less than or equal to negative 2/3 x plus 4 means if you graph the line, we could graph it in this point, slope-intercept form. And if you're graphing by hand, of course you can graph it from that. Go ahead and plot the y-intercept point 0, 4, and then this tells you I could go like 2 points in a negative y direction and 3 points in the positive x direction. Anyhow, we did that in an earlier video, but so you could draw the line using this slope-intercept form. Now, assuming that we can graph this line correctly, when y gets smaller, less than, well, that happens when we go down from the line, so that the inequality sign, if it's like this kind, means you got to shade below the line. If the inequality sign had been greater than, that would mean you're shading above the line. So you can tell if you're shading below or above by just looking at the inequality sign. Graph the line, this means shade below the line. Equal sign means draw the line in a solid, because you're including the line in your solution. So that approach, so here's the line again, and we're going to graph y less than or equal to negative 2/3 x plus 4. So that means we're going to actually shade below the line. That's what this arrow is indicating. You'd be shading below the line. There being a greater than sign, you'd shade above the line. So if I click, we'll shade. And that is a graph of the solution. If it were strictly less than, so here we got the same thing, but strictly less than. The only thing that's going to change is you draw the line as a broken line, dotted line. That means that the graph will not include the line. Shading will look the same. This is just indicating that you're not including the line. So if you were drawing this on a piece of paper, you gotta, make it noticeable that that's a broken line. And then when you shade, be careful when you shade. That's what the shade with a computer, isn't it? Now, what I want to try to do now is I want to try to graph the intersection of two of these guys. So now we're getting to the big league here. Intersection of two of them. Well, to do that, you want to literally graph this inequality, graph that one by the techniques just discussed, and then look at what they have in common. Okay, so when we're going to graph this inequality, we got to graph the corresponding equation as a dashed line, because it's strictly greater than. When you graph this inequality, you got to graph the corresponding line as a solid line, because we're including, equal sign here, we're including the line. So there are the two lines. You got a dashed line for one and a solid line for the other. I put them in different colors. Now, what we're going to do, there's the picture there, is use a test point. I'm going to use the test point method this time. So I'm going to test the point 0, 2. You just got to pick a point that's not on either one of the two lines. And then you check and see if this coordinates of that point satisfy each individual inequality. So using a test point 0, 2 on this one, I check, I get 6 greater than 12, which is not true. So I have to shade on the side of the graph of, and I put it in red. See, I got, this is the equation corresponding to that inequality. I drew it in red because it would correspond to this line right here, line in red. So when we shade this one, we got to shade away from the test point. Okay, well that means if I go ahead and shade this thing here, and I got it in red. So okay, so we're shading away from the test point. This is for the red one. So that means that part of it is going to be shading up here. And then when I check the other one, this inequality, and I check the test point again of 0, 2, I get 6 less than or equal to 12, checking this one, which is true. So I got a shade on the test point side of the blue graph. Maybe I'll make my ink color blue then. So I'm going to shade on the test point side of the blue graph. So that's going to be shading in there. And now what we got to do is figure out what they have in common. Well, you can see they're going to have this part right here in common. So let's get my pointer back and go on to the next one. So the intersection of the graphs of the two will be the region that is shaded that they have in common. That's going to be, doing it like this. So we got the shade up here, shade down there, and then what the two of them have in common is this darker shade in there. So that little neater picture will be the graph of the system of, in effect, two inequalities, graphing what they have in common. Now we could have done it using arrows. We could have taken the two inequalities and each of them solved for y. The danger there is you got to get from where you were to this correctly and to that correctly. But if you do that, that would mean that the what's going to be a red line for this one, the dotted line, broken line, and you'd be shading greater than above it. And if I draw a blue line for this one, solid, including the equal sign, and less than means shade below the blue one. So shading above the red one and below the blue one. So there's using your arrow approach. Here's the blue line, solid, shading below it. The red line, a broken line, shading above it. And you can see I filled in what they would have in common. There was that test point that we used. Kind of cool. Yeah, if you can do that, you could go to the mall, get yourself a box to stand on, and tell the world what you can do, because it's pretty cool that you can do that. At least I think it's pretty cool. This time I want to graph the intersection of y greater than or equal to 2x minus 3 and x greater than 2. So you need to graph the line associated with each. We'll graph this line as a solid line, including the equal sign. We'll graph this line as a dashed line. And remember now, x equals 2, that's a, what kind of line that is? A line along where x should be 2 every place on the line. So it's going to be perpendicular to the x-axis out there, x equal to 2. Vertical line. Okay, so here we go. We got the x equals 2 line. It's a broken line. And then here's the other one in solid blue. So those are the two lines that are going to be the boundaries of what's going to be the solution to our system of inequalities. Literally two inequalities, what the two of them, which satisfies both of them. Now the values of x get larger as we move to the right. So to graph x greater than 2, we need to shade to the right of the graph of x equals 2. Because if you go to the right, x getting larger. And you want x larger than 2. Values of y get larger as we move up. So when we graph this guy, greater than, got to move up, got to graph above this one. Meaning you're standing on any point on the line, you're going to graph straight up. You can graph like that, but it's the same result. So I got to shade above the graph of this line here. So using arrows, here's the vertical line, x equal 2, broken line shading that direction, and then here's the solid blue line that we're shading above. And so there's shading this way from the red line, there's shading above, or literally that way from the, look at that way from the blue line, and then that's what they got in common. So there's your solution, what they have in common, those two inequalities. You're literally solving a system of inequalities. Wouldn't it hurt to actually learn how to solve systems of equations? Then you could tell exactly where this point was right here. That point right there would be the solution to what's called a system of equations, whose graphs will be these two lines. And we'll look at ways of doing that. Now I want to graph the intersection of y less than 4 and 2x minus 4y less than or equal to 8. So now we've got to graph two lines, y equals 4, be a dashed line, not a solid line, no equal sign with it. And I got to graph this line as a solid line, because it's got an equal sign with it. So there are the graphs of those two lines. This time I'm going to use a test point. I'm going to test 4, 2. So we want to take a look at where 4, 2 is, and then figure out where to shade based on that. So if we test the point 4, 2 in this inequality, which is related to the blue line. Putting in 4 for x and 2 for y, we get 0 less than or equal to 8, which is q. So we're going to be shading on the point side of the blue line. Here's the blue line above. So when I plot that point 4, 2, we're going to be shading on the point side of the blue line. So there's the point, 4, 2, and now we'll be shading on the point side of the blue line. Or had we used the arrow direction method, like they're telling us we're going to be shading on that side, because here's the point, that side of the blue line. When we look at y less than 4, this is the line y equals 4, and y does get smaller as you go down. So to graph y less than 4, broken line, less than, not including the line, no equal sign, and shading down. So we're going to be shading up from the blue line, down from the red line. Let's see what they have in common. Well, there's up from the blue line, there's down from the red line, and it darkened up what they had in common. So let's just click again, and that'll get rid of the other stuff, and you're left with the shading that is in fact the solution to the problem, this system of 2 linear inequalities. Graph of your solution there. Pretty cool, huh? And again, the alternative is I could have graph that by solving for y, and y greater than or equal to 1/2 x minus 2 would have told me how to shade. Of course, you gotta first solve for y to use this method, but that